Hi there, Mrs. Wagner here. I am just going to quickly go through what you're going to do for Lesson 10. So you're going to open up your slide deck for today, Lesson 10, Day 1, and you're going to write the two investigative questions in your notebook. What is the difference between a hot and a cold liquid? And why do particles move more in hot liquids? Yesterday and the day before, we did a lab and did some whiteboarding on movement of energy across a wall cup. And our whiteboards demonstrated that particles do move and that they can move at different speeds. We also talked in our whiteboard meeting about energy transfer from one type of liquid to another type of liquid in terms of temperature and energy. So we're going to kind of explore that idea a little bit more and do a little bit more modeling. So what you're going to do is, first of all, set up your notebook. So you're going to write this question in your notebook, and I'm going to share with you what that looks like. So Day 1, Lesson 10, and you write the two questions. And then you're going to continue on in the slide deck, and I'll have slides that show the pictures of each of these pages so you know what your notebook should look like. So you're going to then go to slide G, and before you do that, what you're going to need to do is draw these models where you will be drawing particles inside this zoomed in image of what particles look like in hot tea versus what particles look like in iced tea. So get that set up first. Then you go to this slide. It says, imagine a cup of hot tea and a cup of iced tea. The cup of hot tea has heat and the cup of iced tea has quote unquote cold. If we zoomed in to the particles that make up the tea in the two cups, what would be similar or different about them? So draw your models in each of those zoomed in images. Then on the next slide, we're going to call this slide E. And they don't really go in order. They're just labeled those slides, but they don't necessarily go in alphabetical order. It's fine. Here is what the notebook will look like. So we're going to label this slide E, dissolving candy. And you're going to write out, as you watch the video, 3 notices in the video. What do you notice? 3 of them. And what do you wonder? 3 of those as well. Okay. Then you will also see another video in another slide, so you'll go to the next slide, and you're going to watch a short video on what's going on with food coloring. And again, what do you notice about that food coloring, and what do we wonder about that food coloring? So there's the candy dissolving, and there is the food coloring. Then you'll go on to the next slide, and you will get a handout. So you'll grab this handout, and I'll share what that looks like. This is the handout. So you're going to glue this in, and if you need to cut it down, you can, or you can just fold it. So if it is not fitting into your journal, you can just do the sheet first, and then you can fold it like this, and then just glue one side of it, glue the back like this, and then you have a little foldable in your science notebook. So whatever works best for your notebook. It says that you saw a video of candy dissolving. You also saw a video of food coloring. So now we're going to draw what those models look like in those 3 different temperatures of water. So you'll get this in your video on slide 9. I am pretty sure it's slide 9. It might not be, but you'll find it. It's in lesson 10. You're going to watch that particular simulation. So it says how molecules move simulation. So you'll click on this. It will take you to the simulation. Okay. So here's the simulation. You just hit play right there and watch the molecules move. And you can move the temperature bar and make your molecules warmer and cooler. Make some observations. And then you'll go back to your notebook and you will answer number 1. You will do number 2 using circles to represent water molecules. Draw a model of the molecules in cold and then also hot. And we've given you already room temperature. Then you have a question that you're going to answer. where you have two graduated cylinders. Okay, let's say you measure exactly one, actually you just have one graduated cylinder and you measure it with 100 milliliters of water. And then you heat the water to 100 degrees Celsius and you notice that the volume increases to 104 milliliters. You didn't add any more water. All you did was heated up the water. So using what you know about attractions between water molecules and the way heat affects molecular motion that we learned in our simulation and that we learned in our videos, explain why the volume of water in your heated cylinder increases when it's heated. And you will answer that at the bottom there. After that, slide F, you're going to label this balloon bottle. Again, a notice and wonder T-chart. 3 notices and 3 wonderings. Then you're going to write out a definition of kinetic energy, and then, I got a little smudged, and then I would like you to describe the kinetic energy in a solid, kinetic energy in a liquid, kinetic energy in a gas, and then answer this question: why do gas particles move the fastest? Once you get your notebook done, on that page, you will go on to slide F. You will watch this video of a balloon bottle in water. Actually, you have 2 balloon bottles in water. And you will do your 3 notices and your 3 wonders. There you have definitions of your kinetic energy. You have your solids, liquids, and gases to help you answer the last question in your journal for today. And then you are done. Have a great day.